All right, welcome to my Project Euler series. Let's see. So, we're going to be looking at problem 8 on Project Euler. So, this one doesn't seem too bad. It looks a little intimidating at first glance, but I don't suspect we'll have a huge problem with this. So, we're given this huge number here. What we want to do is we want to find the largest string of 13 adjacent digits in this number, and what we want to know is, well, what's the product? Yeah, we want to find the largest product of 13 adjacent numbers in this 1,000 digit number. So let's go ahead and get started. I already have PyCharm open. Let me just go ahead and copy and paste this into PyCharm. Let's see. So big, we zoom in. Big num is equal to this guy. I don't think you can read it in, so I'm going to read it in as a string. Does that work? No? Boom. Let's see. Boom, 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 boom. Hold on 1 second. Make sure my chat's open. Let's see. Okay. Let's see. So let's see. Big num is equal to int list big num. So I think this should convert it into a list of integers. No, we're not even running the right problem, and we didn't even print it out if we did. Print big num. Run problem 8. Let's see, it's angry. What is that? Invalid syntax. Invalid syntax. It doesn't like this equal sign? I think that's pretty standard. I think that's pretty standard procedure. How would I just say print big num before we try to convert it into a list? Oh, okay, good. Didn't like this. Okay. So we got this huge string. I don't see any spaces in there, so I don't think there'll be a problem with that. Let's say big num is equal to int list big num. Argument must be a string or a number, not a list. Okay, so we have a list of characters. I mean, we could work this way. Like, say, we could do this as we're kind of iterating through every element in this array, I think. Right? It doesn't matter too much. I mean, I kind of wanted to just convert it all into integers on the fly, but whatever. So let's just kind of work with it as an array of characters. So for I in range length of big num minus what, 13, 14, I don't know. 13, let's say 14. I think that's how it's going to work, because we start at 0, so blah, blah, blah. Actually, I don't know. You know, let's just try. Let's see, biggest product equals 0. So we're going to run through this. We're going to say, okay, well, biggest product is equal to, or let's say current product at index I, say equals 1 for I in let's see, big num I through I plus 13. We'll just do something really simple with this. Let's just print I. Let me look at the top here. 7, 3, 1, 6, 7. Let me count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Looks like it works. Current product is equals I, and then we're going to reassign the biggest product if we get a better product. Simple. Alright, let's see what we get. Print biggest product. Oh, not so simple. Oh, we didn't convert it to an integer. Ooh, big number. Let's see if it works. 53727. Check it. We got it. Simple. Moving on. Problem 9. A Pythagorean triplet is a set of 3 natural numbers, a, b, c. Let me check something really fast. Pythagorean triplet is a set of 3 natural numbers, a, b, and c, such that yada yada yada. Okay. This, also seems pretty. We're still in the easy phase of these, Project Euler problems. So these seem a little too simple. Just give it time. Trust me, these get way harder. We're still in the honeymoon phase. Let's see. Let's create a new Python file, problem 9. Okay. So, let's see. A Pythagorean triplet is a set of 3 natural numbers, none of them equal, such that a squared plus b squared equals c squared. Okay. This seems pretty simple. So, we're just going to do a kind of a 3-fold nested loop for a in range 0 through 1,000. For b in range, I'm going to say a plus 1. Since remember, a is strictly less than b. 1,000 and c in range p plus 1 through 1,000. Okay, so what we want to do is we want to check if their sum is equal to 1,000. If A plus B equals is not equal to 1,000, then what we pass, right? Is pass the same thing as continue in C++? Continue equivalent in Python. Or is the continue equivalent just continue? What's the difference between continue and pass in Python? Continue statement returns the control for the beginning of the while loop. What does a pass statement do? A pass statement in Python is used when the statement is required syntactically, but you don't want any command. Okay. So the Python equivalent of continue is, what do you know? It's continue. Now, if A squared plus B squared equals C squared, what you want to do is we want to print their product. Print A times B times C, and this, and you know, given the assumptions of the problems, this should only give us an output once. So let's run problem 9. This might take longer than I expected. Let's see, 1,000 times 1,000 times 1,000. Well, took like, what, 5 seconds? Let's see if this gives Daddy what he likes. 71314. Where's an I? Confirmation code entered was invalid. 57885. No ambiguity here. Cool. Another one bites the dust. Let's see. Problem 10. So the sum of all primes below 10 is 2 plus 3 plus 5 plus 7. That's equal to 17. What we want to do is find the sum of all primes below 2 million. Okay. So it's not easy. I mean, it is easy, but who knows how long it'll take to run. Let me put this piece of text on my screen for you guys. Find the sum of all primes below 2 million. Nice and centered. Save this guy, new Python file, problem 10. So we're getting into the double-digit range. Alright, so I am going to import my isPrime function. Where did I originally have it? I had it over here. I think I used it again in problem 7, yeah. It's a little bit cleaner looking over here. Actually, I used it in problem 8 as well. No, I just did problem 8. Yeah, let's copy and paste this guy into problem 10. You know, I want this I equals 2 over here. So this is my method for just determining whether or not a number is prime. It's a very naive implementation. You know, maybe there's like some fancy tricks you can do. I'm not a number theory expert, but you know, it's like, okay, let's all go all the way up to the square root of that number, and if we can't divide it by anything, then it's prime. That's really all she wrote. So sum equals 0 for, okay, and let's start at I equal to 2. So while I is less than 2 million, 1, 2, 3, if I is prime, then we're just going to add to our sum. Sum plus equals I. And print out when we're done. Print I. Let's see how long this takes. Let's see, import time. Import, I'm just curious. Let's see, start time equals time dot time. Print total runtime is equal to time dot time minus start time. Right? I think so. Oh, we're running the wrong problem. Run problem 10. Print running. Print finished. It's taking a while. Let's see. Print I. So I just kind of want to see, I just kind of want to intermittently see like what number it's at. Well, it's taking a while just to get up to 100,000. Oh, you know what? There's a reason why it's taken a while. We didn't increment I, it's just stuck at 2. You know, that's the thing with kind of running while loops. Occasionally forget little things like that. Oh, didn't import math. $100,000, 200,000. It's climbing. All right, and this is where we sit back and enjoy the ride. They say these problems shouldn't take more than a minute for your program to run. There's got to be a more efficient way of doing this. What it is, I have no idea. If you have any ideas, I'm all ears. But I don't know. Maybe this'll take less than a minute. We're not done yet. I'm gonna say 55 seconds. 59. Now, if I was running this in C++, I think this would take maybe like 10, 15 seconds. Oh, a minute and a half. And it didn't even give us the right number. Oh, we didn't output the sum. Oh my god, I'm such an idiot. Man. Alright, one more time. 100,000, 200,000, 300,000. Alright. So, I guess I can think about it like, what's the more efficient way of getting all the primes below 2 million? Besides just kind of iterating through all of them, and then doing this like nested loop inside the is prime. Like, I think, I looked this up. This naive implementation is, maybe not optimal, but it's pretty damn close. It's pretty hard to do better. So I think there's a trick that involves me not going through, all numbers less than 2 million. There's some things that are already implemented in this is prime function that, like I check if the number ends in 0, 2, 4, 5, 6, and 8, and it breaks immediately if it does. But, besides that, what else can I do within, outside of that is prime function to speed this up? It seems like the only place where, optimization could happen. Is there a formula for calculating primes without checking every number? I did look this up on Stack Exchange the other day, and there are some tricks, but they don't look like they will improve the speed very much. Formula for fast checking prime. Let's say algorithm. This isn't what I was looking at. Let's see. Such as this page, primality test. Oh, there's this whole page on Wikipedia. The following is a simple test in pseudocode for not very large numbers. Yeah, this is the naive implementation, I believe. Looks like the naive implementation. Return false if n is less than 3, if n mod 2 equals 0 or n mod 3 equals 0, return false. If I less than... This looks a little bit better than my implementation. I'm going to try this out. Let me copy and paste this, because it's a little bit different than my implementation. Let's give this a try. I don't want to, I'll just copy and paste it from problem 5 if this doesn't work for whatever reason. Let me revise this. Def is prime. Let me just format this so it looks like Python code. Less than equal to false, true. Equals. So I'm just doing a lot of formatting here just to make this look like Python code. Why did that shift over? Okay. Oh, it's because I think Python looks like ELIF. Is that right? Else if. Okay, it's the compiler seems happy with that. Less than or equal to n. Let's see, I equals 5. So n, if n mod 2 equals 0, or n mod 3 equals 0, return false, return true, return false, n mod I equals 0, or n mod I plus 2 equals 0, return false, else I, oh, you know what, we can just like increment by 6. That's a pretty nice trick, instead of incrementing by 1. So yeah, this should increase this is prime function by a factor of 6, I assume. That seems pretty reasonable. You know, I'm gonna input this. Alright, let me copy and paste this guy and see if this works first before, but I want to rerun this just to see if this speeds things up a little bit. 63407. That works, so that solves the problem. Let me see if this speeds things up. So I have 92 seconds right now. Let's see how quickly it runs now. Invalid syntax. Colon here. That runs a lot faster. That is awesome. Very cool. Yeah, it looks like it gave me the same number. Alright, cool. Thank you, Wikipedia. Let's move on. Largest product in a grid. Okay, this is kind of similar to, you know, the problem I started off with. Let me open up a new Python file. What should I call it? How about problem 11? So for problem 7, or was it problem 8? So for problem 8, we were just kind of multiplying, you know, across here. We're just trying to find consecutive digits in this number. But here, let's see what we want to do. We have a 20 by 20 grid. Find the product of these numbers, or find the largest product of 4 adjacent numbers in a given direction, up, down, left, right, or diagonal. Okay, this one seems a little bit more, I mean, it's definitely more involved than problem 8. Not hard, just maybe a little tedious. So let's go ahead and create a variable called number grid, and this is equal to this guy here. And I want to input this as like, let's see, how many numbers is this across and down? So 1, 2, 3, 4, 5, 6. Does it say? 20 by 20. Okay, this is a 20 by 20 grid. And let me copy and paste this onto the screen. Okay. So let's see, what I would like to do is I would, convert this into numbers and then convert that into a 20 by 20 array. Print list. number grid, I don't think this will work. Oh, wrong problem. Run problem 11. Yeah, so what you see is happening here is it's splitting up the 0 and the 8. It's thinking of these as two numbers. Let's see. How do I make, what's an easy way to do this? Oh, I think you do a string split. Let's see, split a string in Python. Okay, yeah. Seems pretty easy to do. Number grid, split. Okay, it split up the space, but it didn't do it places like over here. Okay, let me just add a space at the end here. Okay, and let me do a little test here. Print int number grid 0. Just to make sure that output's 8. That outputted 0. Oh, I don't like that. Don't like that. Why doesn't it recognize 08 as just 8? I should remove, let's see, if it starts with a 0, I should remove that 0. So let's go through the, okay, let's just say number grid is equal. So, you know, this first, I'm not even working on the problem yet, I'm just kind of formatting the problem, getting the inputs into a format that I like so I can work with. Let's go through the number grid and remove that 0 if it starts with a 0. Actually, let me try just an arbitrary 2-digit number. So let's try this 22 over here, the third element in that array. Let me see. Let me make sure that outputs a 22. Okay, it works there. It just doesn't work if it starts with a 0. So for num in number grid, let's see. How do I remove a character in a string? Character from string in Python. I think it's just dot remove or dot replace. Let's do dot replace. Now, because what if it's like 50? You don't want to change that to a 5. Only on the first. Yeah. Let's see. I only want to do it, you know, if it starts with a. Let's see. If num, how do I check if it starts with? Are strings character arrays in Python, or can you treat them like character arrays? Print. Yeah, it looks like you can. Yeah, if equals 0. Then, and I don't think there's any 0 zeros in this. Oh, there is a 0 0. Okay. Num 0 equals 0. I just want to replace first element, replace first character in string in Python. No, I just want to remove first character in string. I don't want to replace it, I want to remove it. Yeah, that seems pretty easy. Let's see. Then num is equal to num1. Let's make sure it's an int. Else. Okay, and let me print out this number grid. Yeah, it didn't do what I wanted it to do. Yeah, that makes sense. For I, let me do it this way. For I in range length of number grid, then it makes total sense. Okay, this, yeah, this looks good. I got a 0 here. Okay. Yeah, 15, 0, 40, 0, 75. Okay, this, yeah, this looks good. Now I just need to kind of collapse this into a two-dimensional array. So collapse array into two-dimensional array. I guess we should just do this the messy way. So let's define a two-dimensional array. Let's see, so this isn't even a number grid, this is just numbers. Okay. Grid equals 0 for I in range 20, for j in range 20. Let's print this grid. This is a two-dimensional grid, correct? Yeah, and let's just kind of go through it. So for I in range 20, for j in range 20, so grid I, j, is equal to what? Number grid. What would be the index of the number grid? It would be 20 times j plus I. I don't know if this is going to work. Let's try it out. Let's see, 8, or is it 20 times I plus j? I think that makes a little more sense, to be honest. 8, 2, 22, 97, 49, 49, 99, 81. Okay, cool. That works great. So let's say I wanted to find grid Uh, 19, 18. So let's see, 19th row, 18th column, so that should be 67, right? Cool. All right, I'm going to stop here. I'm going to finish up this problem tomorrow, but I think from here it's going to be pretty straightforward. So actually, I'm only going to be streaming Monday through Friday at 12, so let's see, I had a user submit a pretty cool problem to me, but I'm not going to work on that today. But yeah, I'll be back Monday. Thanks for watching, guys.